All right, everybody, welcome back. You ready to dive in? This time, we're tackling something pretty incredible,
Pretty incredible, yeah.
the human brain.
The human brain, yeah. Fascinating stuff.
We've got some amazing research lined up to really break down the basics, and maybe even a little bit more than that.
Yeah, I think we can all relate to this. We all have one,
We
right?
all got one. We've all used it today, hopefully.
Hopefully. Well, even if you weren't using it, it was still working.
That's true. I mean, it's always on. So let's start with, I guess, the foundation.
Sure.
Like the big picture. When we talk about the brain, what are the major players?
Well, you got to start with the big three. You've got the cerebrum, the cerebellum, and the brainstem.
Okay, the big three, it's like a power trio of rock stars up there.
It really is. Each
Yeah.
one has its own specialty, its own instrument, but they got to work together to make the music.
I like that.
Okay.
Okay, so let's break them down one by one. First up, the cerebrum. What's its deal?
So the cerebrum, that's the big one. That's the one everyone pictures when they think brain, right?
Yeah, the wrinkly dude.
Exactly, all those wrinkles. It's the largest part, and it's responsible for all the things that make us, well, us, thinking, language, memory, emotions. It's all happening up there in the cerebrum. And you know those wrinkles, they're actually crucial.
Oh, yeah. Why is that?
Well, it's like nature's way of packing in as much surface area as possible. More surface area, more brain power, more complex thought.
Huh. So the wrinkles are a good thing. It's like a super efficient design.
Exactly. It's like I don't know, folding up a giant sheet to fit it into a small drawer. You get more bang for your buck, so to speak.
I like it. More bang for your brain buck.
Ugh.
Okay, so we've got the cerebrum, the lead singer. Next up in our rock band analogy, the cerebellum. What's its role?
The cerebellum, that's the drummer, keeping the beat, making sure everything's running smoothly.
Keeping the rhythm.
Precisely. It's all about coordinating movement, balance, making sure your actions are smooth and effortless.
So, like, when I'm riding a bike and I don't even have to think about it.
That's your cerebellum doing its thing in the background.
Wow, that's pretty amazing. We take it for granted. All right, so we've got the lead singer, the drummer, who's our bassist.
Ah, the brainstem. That's the one laying down the foundation, the heartbeat, the breathing, all the essentials.
Keeping us alive.
Keeping us alive. Yeah, you could say it's the unsung hero of the band. It's the oldest part of the brain, evolutionarily speaking.
Oh, wow, really? The oldest?
Yep, showing you just how fundamental these functions are for survival. Been around a long time, working hard.
Okay, so we've got our power trio, each with a vital role.
Yeah.
But it's not like they're just doing their own thing in isolation, right?
Oh, absolutely not. They're constantly talking to each other, exchanging information, working together.
It's got to be a pretty busy network up there.
It's like, imagine a bustling city, right? Each region has its specialty, but they're all connected by a crazy network of highways.
I see it. Like a constant flow of traffic.
Yep, a constant flow of signals zipping back and forth. And the cool thing is, with technology like fMRI, we can actually see this traffic in action.
Really? We can actually see the brain working.
Yep, it's mind-blowing. Like, you show someone a scary picture, and you see this burst of activity in the amygdala, the emotion center. It's like watching thoughts and emotions light up.
Wow, so we can literally see what's happening inside someone's head. That's incredible.
It really is, and it's helped us learn so much about how different parts of the brain work together.
Okay, so we've got this amazing, bustling city of a brain. But what happens when there's I don't know, a roadblock?
Ah, you mean when things go wrong?
Yeah, like when there's damage to a certain area, like from a stroke or something.
Well, that can definitely throw a wrench in the works.
Ah,
Disrupt the flow of information, cause problems depending on where the damage is.
so like if someone has a stroke that affects the cerebellum, that could mess with their coordination.
Exactly. They might have trouble walking, balancing, things like that.
That makes sense, given what we know about the cerebellum's role.
Right, but here's the really amazing thing. The brain has this incredible ability to adapt, to rewire itself. We call it plasticity.
Plasticity, huh? So it can change and heal.
To a certain extent, yes. It's like the city rebuilding after an earthquake. New pathways form, new connections are made, and sometimes functions can be rerouted, kind of like finding a detour around that roadblock.
So there's hope for recovery even after serious brain damage.
In many cases, yes, it's a testament to the brain's resilience and adaptability. Of course, the extent of recovery depends on a lot of factors, the severity of the damage, the individual's age, things like that.
That's incredible, though. It makes you realize just how powerful the brain really is.
Absolutely. And speaking of powerful, there's one area we haven't talked about yet that's particularly fascinating, the frontal lobe.
The frontal lobe. I've heard it described as the executive center of the brain,
Yeah.
right?
That's a good way to put it. It's the part of your brain that's in charge of planning, decision-making, impulse control, all those higher-level functions that make us, well, rational human beings.
So when I'm trying to resist that second piece of cake, that's my frontal lobe doing its job.
Exactly. It's the voice of reason, weighing the pros and cons, trying to keep you on the straight and narrow.
Well, sometimes it wins, sometimes it doesn't. It's a tough battle.
It is. And here's the thing. The frontal lobe is one of the last parts of the brain to fully mature.
Oh, really? So it's still developing even as we get older?
Yep, well into adolescence and even early adulthood.
Wait a minute. So teenagers, they're running around with, like, partially developed frontal lobes.
That's a bit of an oversimplification, but yeah, there's a lot of development happening in that area during those years.
Okay, that explains a lot. The impulsiveness, the risk-taking, it all kind of makes sense now.
Right. The frontal lobe is still learning to regulate emotions, make sound judgments, think about long-term consequences. It's a crucial period of development.
Wow. This has been a fascinating crash course in brain anatomy. We've covered the big three regions, the cerebrum, cerebellum, brainstem,
Yeah, the power trio.
the power trio. We've
Wow.
talked about how they communicate and work together, the incredible concept of plasticity, and even the frontal lobe's development.
And we just scratched the surface, really. There's so much more to explore, so much we still don't know about the brain.
It's a pretty awe-inspiring organ. It controls everything we do, who we are, how we experience the world.
And it has the potential to do even more. Who knows what we'll discover in the years to come?
Well, that brings me to my final thought for our listeners today. Knowing what you now know about the brain's complexity, its ability to adapt, and the sheer power within that frontal lobe, what aspect fascinates you the most about its potential? Think about that. We'll be back next time with another deep dive into a fascinating topic. Stay curious.
Stay curious, absolutely.
All right, thanks for joining us.
My pleasure.